continue with the WASSCE questions on circle geometry, and this one is from year 2009, and it's question 7b. Question 7b. Let's have the diagram first of all. That's a diagram. Now, the question in the diagram: O is the center of the circle. Angle OQR is 32 degrees. That's this angle. And angle TPQ is 15 degrees. That's 15 degrees. Calculate Roman figure 1, angle QPR. Roman figure 2, angle TQO. Okay, let's see that angle Roman figure 1, angle QPR. First of all, we know that angle QPR. No, let me say angle QOR is equal to 2 times angle QPR. That simply means angle at center is twice angle at circumference. So angle QOR, which is this angle, is twice angle QPR, which is this angle. Now, I need to find angle QOR first. I know that angle OQR is equal to angle ORQ. The reason is because OQ is a radius and OR is also a radius. So triangle OQR is an isosceles triangle, and that means its base angles are equal. So if this is 32, this also be 32 degrees. So that therefore means angle ORQ is also equal to 32 degrees. Now that I know angle ORQ, I can find angle QOR. That means angle QOR plus, this is angle QOR plus 32 degrees plus ORQ is also 32 degrees plus another 32 degrees is equal to 180 degrees. Let me make my diagram neater. So I want to say angle QOR plus 32 plus 32. That means angle QOR plus angle OQR plus angle ORQ equals 180 degrees. Sum of angles in a triangle, and that simply means angle QOR equals 180 minus 32 plus 32 is 64. When you move that to the right hand side, it becomes minus 64. So angle QOR equals 180 minus 64 is 116 degrees. So therefore, this angle QOR is 116 degrees, and that means angle QPR, which is the one we want to find, that means angle, we already said angle angle QOR is 2 times, let me write that again, angle QOR is 2 times angle QPR, and that simply means angle QPR equals angle QOR divided by 2, and that's 116 over 2, which is 58 degrees, and that's angle QPR. Very, very simply, we go straight to the next, which is Roman figure 2. Find angle, calculate angle angle TQO. Okay, let's see that. Let me have a Roman figure 2 here. That's a diagram again. We want to find angle TQO. First of all, let me join T to Q. Yes, and then T to O. So yeah, so we want to find this angle TQO, which is this angle. That's it. Now, if angle TPQ is 15 degrees, then that means angle TOQ will be equal to 2 times 15 degrees, which is 30 degrees. So angle, and the reason for that is angle at center is twice angle at circumference. Angle TOQ equals 2 times angle TPQ. Angle TOQ, which is this angle, is twice angle TQP, which is this angle. So that simply means angle TOQ equals 2 times 15 degrees, and that's equal to 30 degrees. Now this might look a little tricky, but it's not difficult. Let's look at that. We can see that if we join T to Q, we have a chord that's called TQ. You would see that this angle TOQ, which is formed at the center of a circle, yes, is formed such that there are two lines, TO and OQ, which form a triangle with the chord TQ. So you just look out for any other two lines which also form a triangle with that same chord TQ at the circumference. Those two lines must meet at the circumference. So the angle formed by those two lines at the circumference is going to be half of TOQ. So we can see that the lines TP and PQ form a triangle with the chord TQ, and they meet at the circumference to form that triangle. So the angle formed by those two lines is going to be half of the angle formed by the two lines that form a triangle that meet at the center to form a triangle with the chord TQ. Let me go over that again. You see that if you join T to Q, you have a chord TQ. Now you can see that lines TO and OQ meet at the center to form a triangle with the chord TQ. That simply means any other two lines that meet at the circumference to also form a triangle with the same chord TQ will form an angle which is going to be half of TOQ. And we can see that lines TP and PQ meet at the circumference to form a triangle with the chord TQ. So that means the angle formed by those two lines, which is given as 15 degrees here, is going to be half of the angle formed at the center. So that means that's a trick for identifying what angles are circumference and center angles. So that means angle at center is twice angle at circumference. So that means TOQ, since we already know TPQ to be, we're already given TPQ, and that's 15 degrees. So that means TOQ is therefore 30 degrees, which is 2 times 15 degrees. And we can see that OT is equal to OQ. OT is equal to OQ. The reason is they are both radii, and that simply means triangle TOQ is an isosceles triangle, and that means its base radius are equal. So I can say TQO angle TQO is equal to angle TOQ. And what's the reason for that? Base angles of isosceles triangle. Oh no, that's not what I should say. We can see that OT is equal to OQ because they are both radii. So that means the base angles of the isosceles triangle TOQ, let me just write this way, in triangle TOQ, angle OTQ is the same as angle TQO. Angle OTQ is the same as angle TQO. So because they are the base angles of the isosceles triangle TOQ. Now, how do we now find that? Since they are the same, we can just represent them using the same algebraic term. So I'm going to say let angle OTQ, which is the same as angle TQO, be equal to x. So in triangle TOQ, I can say x plus, we already found TOQ, angle TOQ to be 30 degrees. So I can say therefore x plus angle TOQ, which is equal to 30 degrees, is equal to 180 degrees. Sum of angles in a triangle, and that simply means 2x equals x plus x is 2x, when you move 30 to the right hand side, it becomes minus 30. So 2x equals 180 minus 30. And that simply means 2x equals 150. If you divide both sides by 2, you get x equals 75 degrees. X equals 75 degrees. And therefore, angle TQO equals 75 degrees. And that's it, very, very simply. Alright, let's take a breather and then come back for the next. Thank you very much, and I'll see you in a bit. Bye bye.